Hello and welcome back to our FTC Getting Started series. My name is Gordon Dodderman from FTC Team 8372 Trial and Terror, and today we will be going over how to set up Vuforia image recognition.
Okay, so before we get into how to program Vuforia and how to put it into your code, I thought we'd really quickly go over what Vuforia is and what you can get it to do. So Vuforia is code developed by the company Vuforia, and it allows your phone to identify pictures from its camera. So this comes in handy for your phone on the robot to be able to detect the pictures on the field, also called pictographs or VU marks. And these pictographs will tell you different things that you need to do in autonomous, like scoring in a certain column. And if you are able to use it correctly, Vuforia can also tell you your exact location on the field relative to the picture. So Vuforia is really useful. It can be a little dangerous to use sometimes, but we'll get into that later. But it's actually very easy to implement. Now, I've gotten all of this code out of the FTC VuMark concept code, which is in the FTC robot controller external examples folder. So you can just go in there, get all the code. I'll also have all of the code in a document that I'll have in the description if you just want to copy paste from that. I find their commenting to be useful, but also very distracting if you're trying to find certain bits of code. So I'll put that in there. So the first part I'm going to go over is on the left here we have linear op mode. So this is the while op mode is active, that sort of thing. And then on the right here we have our concept event op mode. So this will be, the init class, or not class, the init function, start, loop, stop, all of that. So we'll go over how to implement Vuforia into both of these because they'll be slightly different. So the first part of Vuforia implementation are the instance variables. So you can see they're a little different, but basically you're going to be initializing the Vuforia localizer variable Vuforia, and in event op mode, because of some scoping issues, you'll also have to initialize Vuforia trackables, relic trackables, and relic template. So for linear op mode, these initializations will be between right after the class and before the run op mode, so these two. And then for event driven, you will have them between the class and the init. So you can see where to put that. The next part is going to be the initialization. So starting everything up, putting in the right values for your settings, all of that. So all of this is pretty straightforward. You don't really need to know how it works. You can look it up pretty easily if you need to. But the two lines you really need to pay attention to are the Vuforia's license key and the camera direction. A Vuforia license key, I'll get into another video on how to get one, but it's very straightforward. It'll probably take you like a minute or two. But you will not be able to run the program with Vuforia in it without a proper key. And this key here, the one that will probably already be in your Vuforia code by default, will not work. So you'll have to get a key from their website. And then the other line you can see here. Let me find it here and here. Those two lines are for the camera. So we have basically the ability to change between the back camera and the front camera. So the back camera is the one facing away from the screen, and the front camera is the one facing towards the screen. So this is really helpful if you have trouble with mounting your phone in a certain way or stuff like that. But just keep that in mind. Also know that you have to put it in all caps because it's an enumeration. So keep that in mind. So this part, the from telemetry, or the init int camera monitor view ID to the relic template, that's about what you'll want to be putting in there. So for linear op mode, you'll have it between run op mode and the wait for start, not between the run op mode and the while. Go up to the wait for start. And then for event driven, you'll just have it in the initialization area. So the next part is pretty straightforward. It's just activating Vuforia. So this will happen in the start area. So for the linear op mode, you'll have it in between wait for start and the while. And then in event driven, you'll have it in the start area. So relic trackables.activate. And then this is the fun part here. This is getting all of the variables. So this is the same for both of them. You can put these calls anywhere in your code, just as long as it's after the activation, or else they won't actually give you anything. It might actually crash it. So keep that in mind, but it does not have to be in loop. It can be in start as long as you have activate before all this stuff. So the first thing you can do, the simple thing you can do, is you can tell what your camera is able to see at the current moment. So there are 4 options for what it can be seeing. It can be seeing right, center, left, and unknown. So these correspond to specifically what column you want to score in. It's pretty arbitrary otherwise, but basically, if you score in that column that is depicted by the picture graph, then you will get extra points. So that's something you can tell, and then it'll just tell you if it can't see anything at all. Now this value is stored in the VuMark variable, which gets its value up here. So relic recovery VuMark.from relic template, and that'll give you what the camera is seeing in a pretty rudimentary state. And then the cool part, and also the more volatile part, is the pose. Now, Vuforia is able to tell where the picture is in relativity to your robot, if it's able to see the picture, obviously. Now, it is able to give you your translation in the X, Y, and Z, and it's also able to give you your rotation in X, Y, and Z. Now, what X, Y, and Z, like where that is in relation to your phone, it'll kind of depend. I personally have found that X is facing out of the phone, Y is up and down on the, or side to side on the phone, and Z is the last one. So take that with a grain of salt, but you'll probably have to figure it out. It's pretty straightforward. But this can be very useful for, let's say, if you don't want to use encoders, you can just have the robot, go forward until it's a certain distance away from the picture. However, there is a bit of a more volatile side of it, which is basically the fact that all 4 of the pictures will be the same. So let's say you turn 180 degrees and you all of a sudden see the picture on the other side of the arena. The robot doesn't know that. And so it's going to all of a sudden think that it's on the other side of the arena. So keep that in mind. It doesn't necessarily automatically know which picture it's looking at. All of the pictures will look exactly the same to it. So if you decide to use this method, then just keep that in mind. And that's how you implement Vuforia. It's pretty straightforward. I highly recommend you do it. It's a few easy extra points if you're able to implement it. And yeah, I'll have all the code in the description if you just want to copy paste from that. Or you can get it from the, here, I'll show you right now. So FTC Robot Controller, Java, external examples. And then it's right down here, concept VuMark identification. So you're able to see here that it's just all of the code we talked about, except with a lot of comments to try and explain it.